Hello, everyone. My name is Chris Murphy. I'm a senior technical artist on the developer relations team, and today we're going to be looking at PCG, first steps, there's a dramatic opening, to advanced development. This is a fun session. It's one of those sessions where I don't have slides. It's going to be just in editor. Thank you. It's going to be in editor the whole time. We're going to make some stuff. And this is kind of in response to, this session's really in response to feeling like there's a lot of content floating around right now on learning PCG that is reasonably similar, I guess. There's a lot of people doing very similar stuff with PCG. And there's a few things that we're doing in Epic projects that I really wish other people were doing too. And because of that, I thought I would get on a soapbox for 45 minutes and tell everyone how great it is to do those things. So today's session is really looking at kind of touching on some of the more advanced features and perhaps exploring more about how we're getting some of the high quality that we're really getting from things like the Electric Dreams demo. So with that said, the environment we're going to create is something similar to this. We'll see how we go. I'm going to go ahead and just spin up a empty environment to start with. And because world partition has kicked in, I'm just going to quickly stream in the teeny bit of content that I have. Here we go. Nailed it. Cool. So we have an empty environment. I'm assuming that everyone can generally get this far. And I do, ahead of time, just want to highlight that I have this one spline going through the world. Nothing fancy. I'm going to spend the first couple of minutes kind of catching people up to speed. I'm assuming that there are folks here that haven't used PCG before and you're keen to find out about it. So my aim is to spend about the first 10 minutes or so really touching on just some of the concepts, some of the introductory stuff, and then I'll do my best to kind of 0 to 11. So I'm going to go ahead and I'm going to create a new PCG system. This new PCG system is going to have a very straightforward name. I'm kind of liking PCG_forest. Now, in order for everyone to see what's going on today, I'm going to do my best to kind of have a split perspective. Hopefully this is going to be easy enough for everyone to understand. But with this, the graph I'm doing here, and then the world over here. I'm going to go ahead and drop the PCG volume that I just created into here. And actually, I'll switch to tiled view. Yeah, that'll work a bit better. Cool. With this in here, I'm going to go ahead and start to create something. So I've dragged in a PCG volume. It's nothing too fancy. It's just a big old volume, big old cube. And I want to create some points within it. If I want to create some points on the surface of the world, it stands to reason that the first node I'm going to need is a surface sampler. And it's going to say, well, hang on, what do we need to sample the surface of? And we need to sample the surface of landscapes. So I'm going to drop this in and connect it. And it's at this point that I want to show you the first of the two most important keys when using PCG. And that key is D. D is for debug. And at any given point, you can click on a node and hit D, and it will debug that node and show you all of the points that you're getting up until that point, right? It's worth noting you can also do Control-Alt-D, which is very handy. Control-Alt-D turns debug off on every other node in the scene and just puts it on the one that you've currently got selected. But the other thing that we have here is A. And when you hit A, and you make sure that you've got your components selected down here, A actually gives you a big old list of all of the attributes of the current system that you've got selected. So it tells you the actual hard data being stored in all of these points. So in this situation, if we wanted to mess with that in some capacity, we'd probably say, hey, I want to mess with your transforms, and I want to spin you all 360 degrees. At which point you can see we've got a whole bunch of rotating things. Actually, give me just one moment. I might crank up the size of this volume. Yeah, ship it. Okay, good. So we've got that in play. What I want to do is, we can see that this could already be some ferns or something that we're scatting through the world. But what I'd love to do is point out something interesting. If I hit A and I scroll all the way to the right, we start to get some weird attributes. See, we've got heavy mud, stony ground, fields, plowed soil, et cetera, et cetera. So those are actually landscape data. So whenever you create points, it actually feeds in any information about what's painted beneath it in the landscape at that given point, which is really, really useful. Because if I know that we've got that data, I can use it. For instance, we've got these watery sections over here, and if I hit D, we would be spawning trees or plants or whatever else inside of that, right? And we don't want that. So instead, we're going to spin up an attribute and say, hey, I want to filter based on the attributes. And specifically, I'm going to get this, and I'm going to say to it, let's just plug that in there. I'm going to say, I want to see if, I'm going to hit A so we can see it. I want to see if heavy mud, if I scroll down here, I can see that sometimes heavy mud actually has data in it. Oops, sorry, it's a very sensitive mouse. I can see that sometimes heavy mud actually has data in it, right? And I want to say to it, hey, look, I want to check if heavy mud is greater than 0.2. And if that is the case, this would be how we formed like mangroves or something. You know, this is how we would kind of throw points just into that. On the other hand, instead of greater than, if I switched it over to a less than, this is how we would then exclude points from that region. And if I was to just arbitrarily paint the scene, you know, this would dynamically update as well, which is great. So we can see here that we can pull those points away. I kind of want these representing big old trees at some point. So I'm going to increase the size of the points that we're sampling in the scene. And I think with that, I'm going to quickly just add one last little thing, which is a static mesh spawner. And the static mesh spawner is going to spawn one thing. Normally, I would have a bunch of trees or something in here, but we don't need that. You'll understand what's going on from just one tree. Okay, great. So we've got all these points in. They're doing their thing, right? Now, if I wanted to do something a little more interesting, actually, I might just cut back on that. Oh, too far. Yeah, closer. Yeah, we're good. So let's say we've got a whole bunch of trees in our scene, right? If we wanted to then lay down a whole bunch of ferns at a tighter, coarser grid, I'm just going to change this over to be a fern mesh. I swear they're there. Okay, let's get a lot more ferns. That may have been too many ferns. This is where I start getting picky, and I shouldn't. Sorry about that, folks. All right, you know what? I'm just going to go 0.2, and we'll back away slowly. All right, cool. So we've got all these ferns here. I'll make them a bit more visible by throwing in some debug points so you can see where they all are. But if we had these ferns, quite often they're kind of encroaching on our trees. See that here? If we didn't want that, what we would do is we would leverage the difference node. The difference node is really handy. It literally just lets you kind of say to this thing, hey, this is where all the trees are. I want you to remove them. And over here, these are the points I want you to remove them from. And I'm actually going to hit E to disable the nodes for just 1 second so that we can see it. But if I debug this, and I debug the difference node, when I set the difference to be a binary subtraction, notice that we're now getting no smaller nodes around those, right? This is how we can kind of place these things. Great. So great. We can see how we can now kind of have trees in there and make sure that we're not getting anything encroaching, and that's all good. And it's worth noting that we can do a similar thing as well. I've got this big white line running through the scene. That big white line represents a spline. So I have my surface over here, and if I wanted to, I could write the word correctly. There it is. I could add a spline sampler, and I could sample spline data. Connect that. Now, when you sample spline data, by default, it looks for a spline on the actor that it's currently in, but you can say, hey, look at every spline in the world. You can look by tag or class. So I'm going to be like, hey, I made a thing called BP path spline. Can you find that? And it'll be like, yeah. Cool. And we can see that that's working. If I debug it, we have the world's thinnest line. And again, at any point, if I was trying to figure out what's going on, I can hit A and be like, oh, I get it. You're the length of the current subdivision, but your Y and Z are currently set to a 1 centimeter, right? So if I want to kind of like fatten out that spline, I can modify the extent of it at any point, and I'm just going to multiply, I don't know, 200. Yeah, it feels good. And that gets us this kind of, this spline reaching through the world. And there's no real difference between me getting that and just plugging that in over here. And you'll now see that, like, whenever I was to move this spline, oops, I'm removing it from the ferns, of course. Sorry, folks, I forgot a very obvious thing. I need to remove it from, the trees as well. I was like, oh, you're not doing your thing. What's going on? Okay. So I can see here that now if I was to kind of do that, trees and stuff would make sure they moved, got out of the way, everything was fine. It's getting a little messy though, and this is something that we've started to see. People can quite quickly create these terrifying graphs. So at this point, I just want to flag that you can at any point create a named reroute, and I can just call this spline location. Yeah, sure. And when I spin that up, I can now be like, hey, don't just connect it to that. And hey, copy pasta, throw you in. Look at that. All right, so it's just going to keep it a little bit cleaner. And again, I could be doing the same thing here. Like I could be outputting the tree locations and such. Probably should. Anyway, so that's in play. We're getting somewhere. Just before I kind of move into the more complicated stuff, the last little thing I want to show you is to show you that this doesn't have to spawn meshes. So if you want, at any point, you can call spawn actor, and spawn actor is lovely because it lets you open it up and just say, hey, what actor are you spawning? You can even run blueprint functions on the actors that you've just spawned. But in this situation, I want to say, hey, I want to spawn a decal. And I want that decal to just be a bunch of things that you're just putting in the world. Specifically, I want that decal to be editable. And I'm going to be like, hey, I want that decal to just be this puddle decal that I made earlier, right? And we can now see that we're putting that down. That looks pretty gross right now because our spline sampler is on subdivision. So let's sample the spline every 300 units. And when I do that, I'll go to unlit so it's a bit clearer. We've now got this kind of like darker decal path being set. And again, nothing stops me from being like, hey, whenever we're doing decals, can you be cool and maybe randomize the size and let's randomize the offset between this. Yeah, that looks pretty fuzzy. I kind of just wanted a slightly shakier path. Great. Yeah, ship it. Okay, we're good. Great. So with that in mind, the last little thing I'm just going to show you on this actually is going to be when you grab a spline in the world, if I was to duplicate this, like this is just working, right? Everyone's happy with what we've got. But if I was to duplicate it and do this, only one spline is working, and that's because spline data has an early out that just gets rid of, like, the second it finds one, it's like, yeah, cool, I'm done. So you have to check select multiple, and when you select multiple, you're now going to see that we're able to kind of have multiple splines doing their thing. Okay. Can I get a good crossover for some stuff later on? Yeah, good. Cool. So with that in play, we've now got, honestly, this is pretty close to what a lot of the standard kind of YouTube content's really covering. That's not to slam, it's just that it's just, everyone wants to just teach you some scattering and be like, go have fun. So what I want to do next is I want to start looking at fun stuff. And the first of the fun things that I want to look at is this. If I was to get some static meshes and I was to drop in like, going for more spruce, I'm going to grab this spruce mesh and drop it in. You can tell this is the first time because it's building meshes. Okay, I'm going to grab you and throw in some Icelandic rock. Actually, I'm going to get you out of this decal area just so I can see what I'm doing. Great. And we can throw anything else here. At this point, I got to stop myself from getting carried away, but but now you're all judging me for it, so I feel like I have to do an at least vaguely acceptable job. Art. Okay, yeah, good. And like for the last little thing I'll do is like, let's say we had these ferns, and I wanted to throw a couple on here that were like happy little ferns. Yeah, good. Love it. All right, so let's say we had something like that. You know when you move angle and you're like, actually, that's hideous? Okay, yeah, good. So let's say we've got a tree set up like this, okay? Everything that you see generally is people scattering meshes. We're like mesh. And that isn't great. And the reason that's not great is that it requires so much micromanagement without any artist control, really, for what you're trying to do. But if I was to select all of these meshes here and right-click and go level, create level instance, and it's going to be like, hang on, where's the center point? And I'm going to be like, oh, it's the spruce tree that I added. I can hit OK, and I'm just going to call this like example assembly, because I was raised right, _01. Save it to there. This means that when I go to here, I can kind of at any point drag in another one of these, and that is a level, right? It's a little mini level inside of things. But if I hit Control E at any point, I can then be like, oh, I sure wish my tree was rotated to here. And when I hit save, that tree adjusted its rotation too. Nothing too fancy, but over here, what I can do is inside of PCG, I can go ahead and, oops, sorry, I missed a step. If you right click on the level instance and go asset action, create PCG asset from level, whatever, default, that goes ahead and creates this. And this is a data asset that stores all the information about this level. So in PCG, I can get it and I can load that information. Cool thing is I can copy the points from, because if I hit this and hit A, I can actually see that there's a bunch of meshes and materials and stuff assigned point data. Do you see that there? So I can actually see that the attributes of this node, if I hit D, it'll be somewhere at 0, 0, I would expect, which is, yeah, there you go. So if I hit D, we can actually see that there's a bunch of boxes around where all those meshes would be. What's cool about that is if I put you along, sure, why not? Oh my God, there we go. I can copy that in. It didn't work. It didn't work, but it got close to working. It's copying in, if you actually look really closely, see how every single one of these has like pointy trees coming out of the side? That's because what we're actually seeing here is I'm copying this to this location, but this has no idea about what mesh to show, because conceptually, showing a mesh is really just looking at an attribute. So I'm going to say, hey, I want you to find the mesh called, let's have a look at what it was called, mesh. And now I can be like, And when we do that, that is now spawning in little levels instead of spawning in meshes, right? All right, cool. We can get better. So if we know that we can do that, what else can we do? Well, easy fruit is I've already made one of these for the ability to finish sentences for the spline, right? So if I wanted to, I could theoretically copy points. Here we go, sorry. I could get my spline that we created before, and I could sample a spline PCG asset that I made ahead of time. And the fun thing is I can actually thread this into the same spawner, and you can see here, it's a bit gnarly because I'm tiling it a bit too aggressively there. Good. Actually, just quickly, I'm going to project that data down to the landscape to just make sure it's snapping to it. Okay, good. All right, cool. So that projection node is making sure that the spline is adhering. We're going to clear up that mess a little bit later on. But I can see now that like this is actually loading entire little levels. I'm going to hide the landscape for a second. It's loading this entire little level again and again and again, you know, and realistically I should be adding some random transform and all sorts of stuff. But a really cool thing that we can do from here is this. If I was in this mesh, this level instance, right, and I got this and I was like, hey, I want to put a tag on this mesh. I want this mesh to say keep vertical. And these little ferns down here, I want to say to these meshes that I want them to be considered clutter. I could even say this rock is clutter. What a concept. Clutter rock, right? And the fun part of this is when I hit exit and I hit save and then I go back and I asset action update asset, grabs all the information and refreshes it. And if I was to look at that PCG asset, I can actually scroll all the way to the right and we can actually see that clutter and keep vertical are now just attributes that the points either have or don't have. You get what I mean? And that's cool, because now that I know I can do that, I could be like, hey, what about we have an attribute filter where instead of just plugging in, I want to get them and say, find out if they're clutter. And if they're, because strings are arbitrary, you've got to be, yep, there we go. I want to see if clutter is equal to true. Okay? Because if clutter is false, put the mesh down. We remember that all of our trees were not considered clutter, so that actually seems about right now, right? But if clutter is true, what I want to do is I want to select, I don't know, like 50% of the points. And that'll actually get rid of the other 50%. And when I add that back in, half of the meshes that were tagged as clutter, so you can see here there's like one fern on that. If I come over here, no ferns and no rock. One fern, et cetera, right? So we can kind of add diversity in here. And like, we use this a lot because we might want to do other things too. I'm doing clutter right now, but you know, conceptually, there's no harm in me fixing problems that we've got. Like if I look up here, see a summary of, there you go. Oof, sorry. That's interesting. I don't know what just happened. All right, see these trees? Trees shouldn't do that, right? But in video games, no. So let's not, right? Let's make a new filter and say, hey, I want to see if something has keep vertical. If it doesn't have keep vertical, just go about your business. Move along. If it does have keep vertical, I'm going to plug this in and be like, hey, it would be great if you had an absolute rotation of 360. Oh, that's not 360. 360. And maybe like give it a little bit of pitch just to keep things interesting. But like, notice that now every tree will stay completely upright, right? Like, so we're actually kind of getting somewhere out of this. And this is useful because I can tag stuff with anything I want. I could tag stuff and be like, hey, this point represents civilization. So if these PCG points aren't spawning near civilization, don't allow there to have any chance of axes against trees or barrels or whatever else it may be, you know, so you can kind of over-decorate some of these things, tag the data, and then adjust it. And in future, I think it's in main at the moment, you can be able to have tags that if you write colon after the tag and then a number, it will give a value to that instead of just being a true or a false, right? So I can be like, things to spawn around me, colon 5, and it'll keep a value there as 5 being stored in that particular point. So there's some really cool stuff that you can kind of work with that. And again, I'm kind of merging all of this data together. So worth noting, I'm getting a warning right now. The reason I'm getting that warning is because 2 sets of data are flowing into this, and my splines don't have any trees, so nothing is ever keep vertical in them. So it's just kind of throwing a warning to be like, you never added an attribute to these nodes called keep vertical. I'm going to assume it's false and move on with my life. And that's correct. So that's okay. Normally, I'd either merge them down or add the attribute. All right, cool. So we've got that in play. This is fun. What I'd love to do from here, though, is let's get the example assembly and let's do more. Let's do a lot more. Let's grab a whole bunch of PCG assemblies, like little mini levels that I made ahead of time, and let's throw them in. So what I'm going to do is I'm going to get this example assembly that we've got, and if I wanted this, I need to have an array of all of the things that I want to spawn. And in theory, I can plug this in into this section over here. So I'm going to create an array, going to create a new parameter, and I'm going to set the parameter type to be PCG data asset. Cool beans. And I'm going to set you to array. I'm going to name this ground assemblies. Oh, not assemblios. Ground assemblies, right? And let's go ahead and throw a bunch of these in that I made ahead of time assemblies. I'm going to grab these rock assemblies. I'm going to grab not the path assembly. I'm going to grab this spruce. Cool. And while I'm at it, just because we created one ourselves, let's go ahead and add that example assembly so you can be like, I knew them before they were famous. All right, so we've got that in there. And this isn't going to work, but it is the first thing that anyone's going to try and do. They're going to be like, all right, I get it. I have a value called ground assemblies. So surely if I plug that in, it will load my ground assemblies up, right? And I can see why you would think that. Here's the problem. The load PCG data asset doesn't load an array. It just loads the first thing plugged into it. You know what I mean? Like it just grabs the very first thing. So if I plug in an array to it, it grabbed, I guess, this random rock one that's come in. And that's then kind of being thrown everywhere. So how do I grab an entire array? This thing's even panicking about it. It's like, whoa, 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 whoa. I wanted one thing. So this is the next thing I want to step into, which is subgraphs and loops. So a cool thing is that while in here I can't just do a nested loop, I can loop over a function and I can loop over a subgraph and run it a bunch of times. Because right now this... I'm going to step back one step actually before I get into that because this will help. Sorry about that, folks. I'm very scatterbrained. If I get that array and instead of doing what I'm doing right now, I can go ahead and I can say match and set attributes. I want you to see what this does. If I hit A, I can actually see now match and set attributes takes an array, and when you leave all of its values on default, it grabs that array and it says just assign any point in here a random thing from that array. Do you get what I mean? Like it's just giving me a random list of all possibilities and it's thrown them in there. What's useful about that is if I know that that's what's going on, I can make a loop that basically we grab all of the assets and we create different sets of data that says your tree 1, your tree 2, your tree 3, your rock 1, your rock 2, your rock 3. And we put all the rocks in together, we put all the trees in together, and we run a loop so that we access the PCG data asset, but we only look at the one thing, and we apply that to all of that data set. We access the one thing for all of this data set, and we apply it this, okay? It's a little bit complicated, but hopefully it makes sense when I actually do it in practice. So just going to get this and drag you across. I'm going to create a new PCG graph, which will represent my loop. Okay. And this is going to be called create meshes from assembly. Yeah. All right. So I'm going to have create meshes from assemblies. Create meshes from assembly is basically going to say, I'm just going to set this to be point data. You don't have to do this, but it means that I don't get like casting internally. Good. So this is going to come in and it's going to be like, hey, we've got something coming in. I want you to find, I want you to get the attribute from a thing. I want you to specifically look up the attribute ground assembly. It's called ground assemblies because it copied off and I never renamed it. Then what I want you to do is run that PCG data asset, and I want you to load that asset. So this will now access that information from the very first thing that gets read into it. After it does, I want it to copy I wanted to copy this stuff. Sorry, this is usually a lot easier when you have a full screen to do the graph. But I really want people... Actually, you know what? You're not going to see results for a bit. I feel like I'm talking down my own talk. You're not just going to see any results. So we're going to go through here. We're going to copy that data off. And at the end of it, we're just going to throw that in. So this is very similar to what we just had. But this time around, it's saying, hey, I want you to get an attribute from a point index, which is ground assemblies. Copy that data in. Before, you may have noticed that when we were loading it, there was one called root, and there was one called points as outputs. Root is just a big box that covers the entire PCG assembly. So if I wanted to, I could actually say filter by tag. And I could actually say, hey, just give me points. And that would ignore giving me the big null root box. Cool. Back in my forest, instead of doing this here, I'm now just going to get that graph I just made and drop it in as if it's my own node. I'm going to loop it, which means run it again and again. There's one thing that this won't quite work yet, but that's okay. So this is giving me something again, but it's not giving me the thing that I want. The reason this isn't working still is I said before that we're going to read in different sets of data. We're going to create our own data sets and then read them in. To do that, what I essentially need to do here is partition the data. And what partitioning does is basically look at this variable, whatever you feed in. If you write at last, it gets literally the very last thing that was added to it. Oops, sorry, I want to partition it after I add the variable. Cool. So because this is the last variable, I actually know it'll grab ground assemblies, but I could also just type in ground assemblies if I didn't want to break something. And I can actually see that working as well. If I hit A, I can actually see that there are 10 data sets here. And remember, we added 10 meshes before, so I can be pretty confident that that's working. And when I plug it in, it's building all the meshes. But you can now see that it's placing rocks, it's placing little trees, it's placing whatever else it needs to. It's resizing virtual texture pools. So we can see that we're kind of like starting to get a little more going on. And before, when I created this, I was pretty gentle with the number of points that I created. So let's spin up some more. But like, see how like bringing this in and getting all that data from just different assets, like once we got that little bit out of the way, all of a sudden the capacity to grab an array of entire assemblies, because think of how Nanite works. Nanite is really, really, really good. Sorry, I think marketing would want me to say, Nanite is really, 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 really good at instancing a whole bunch of meshes, right? It's really good at instancing a whole bunch of meshes again and again and again. And if I had 500 unique rocks, it would look good, but it wouldn't really be taking advantage of Nanite. However, when I use level assemblies, I can get a whole bunch of rocks, a smaller bunch of rocks and trees and whatever, and just put them in a bunch of different artistically driven configurations that I can be happy with. And when I've got that configuration and I'm happy with it, I can then get those things, add a degree of randomness to all of them, and then throw them out. Because nothing stops me from being like, hey, why don't I make 50 different spline meshes to sample all of those as a different data set? Which when I say out loud, I probably should have done. So like, the ability to mix those things and really take advantage of the system's in-UE, I think is really important. And I think this is a really good workflow. And if you look at how we did it in Electric Dreams, you'll see that we have all of these level assemblies going on like all over the place. And that's because for things like cliffs and for things like ridges and all sorts of stuff, you know, I could make 12 different arrays here that were more nuanced. You know, like I could make a level assembly array, like a PCG data asset array that stores ground cover, rocks, trees, you know, whatever name I really wanted to give it, and then mix and match those attributes according to the points that are coming in. All right, so I started with that. I want to go through and fix up a couple of things. This is causing me physical pain, so I want to quickly fix that up. So we're going to take a brief departure from some of the more complicated stuff for just one moment. And I'm just going to go down to where my spline meshes were before. So difference node works by getting nodes and being like, hey, you are in my space, get out of here. But that is one data set. Like, I'm not comparing one data set to the other and being like, use this data set to obliterate this data set. Instead, I have one data set that just crosses over itself, and that's not helpful to me. So how do I get rid of this stuff? Well, what I can actually do, and this is pretty useful, is I can find the distance from myself to myself. Cool feature of the distance node is normally when you read the distance node in, you would read in two data sets. So I could be like, find the distance to the nearest tree, find the distance to the nearest rock or whatever, right? But if you read distance into itself, it removes the point that's checking the distance and finds a query to the nearest neighbor, right? So if I find the distance to the nearest neighbor within the nearest 400 Unreal units, and I hit D, at the moment, the distance by default is the spherical bounds. But if I do it from the center of the points, we should get an interesting result here. Oh, sorry. I have to set density from the node. There we go. So what that's actually doing to me is every one of my splines before was 400 centimeters, like 4 meters long, 400 Unreal units. Really depends on whether I'm talking to a European crowd or the US crowd. You can teach anyone metric if you call them Unreal units. So what happens is we've got this set up, and it's basically saying if something is 4 meters or beyond away, it's a value of 1, which gives us that white output. If something is 0 centimeters away, it's a value of 0, which makes the density black, right? And if something is in between that, we've got a gray area. And if I know that my spline is every 400 units, and this one is within 200 units, then something is afoot at the circle K. So what I'm going to go ahead and do is I'm going to say, hey, I want you to filter the density, filter by density. And if we look at this, I can be like, hey, I want you to get rid of all values beneath 0.8, for instance. And alt-click, get rid of you. And what that's actually going to do now is that's now kind of clearing out. Notice we no longer have those points appearing in the middle there. It kind of just got rid of them. In hindsight, what I would actually really love to do is still keep this wetness, because I think that looks good. So I'm going to separate this. Yeah, that makes sense. Cool. So what I'm doing is I'm still placing decals there no matter what. I'm not getting rid of decals, but I am getting rid of, so we get this muddy area instead. And normally here I could actually get those nodes to find some nice intersection clusters or something like that, but this will do. Cool. So actually one last thing, just because I am dying a little inside visually. I care about what you see, I'm going to just really quickly add a teeny bit of scale and a teeny bit of your rotation, maybe -5 to 5, just so that the pieces that we're adding there between 0 and 20, 50, 100. Oh, we went way too far. That was a bad idea. 20. Yeah, good. Just so we have a little bit of variance in there. And it doesn't quite look like the same thing. And even now, like I didn't point it out before, but because we're running our spline data through the other one, it's actually going ahead and removing random bits of the splines that I'd already tagged as clutter, so it helps keep some variance there. Cool, so we've got that in play. That's feeling good. This is feeling good. What I want to do next is actually show a really cool feature that no one really knows about, but I think it's actually the future of PCG, which when I sort of say it like that, feels like the headline of an article you have to click on and then scroll down 4 pages before you find out what the future is. But we're going to go ahead and we're going to get this, and I'm going to enable a thing called hierarchical generation. So right now, how this works is we generate every point in the world, right? We're generating every single point in the world, and that's good. It's all statically baked, but that's bad Because if I wanted to use PCG to create every blade of grass, I kind of don't really want to pre-save every single blade of grass in the world. You know what I mean? Like, the stuff I care about my trees being in the same location. But I don't care about a lot of other stuff. And honestly, there's a lot of stuff that I don't even want to generate unless we go in that part of the world. Like, if you made a 160-kilometer world, you probably wouldn't want to generate little sticks and stones and things like that unless you happen to go out in that particular direction. You know, if your player plays your game and they only ever walk this way and they start in the middle of the map, there's a lot of content and stuff there that, would just be memory overhead and file size overhead and whatever else, right? So what am I doing here? Well, you can set PCG up to generate in grids. So right now, if I was to click on this, every PCG system is just one giant thing, right? However, if I enable hierarchical generation and then in my world, I think I can probably actually keep the graph closed for a little while. If in my world I get this and I say to it, we're not there yet, folks. I say to it that I want my forest to have generate at runtime. And I also want to say is partitioned. Finally, this is the little bit of a gotcha, is PCG creates a thing called a PCG world actor. And what it does is it stores a whole bunch of logic, including treat editor viewport as the runtime generation source. And what actually happens now is wherever my camera goes, it will use that as a generation logic. And notice here, this is now actually split up into multiple things. Do you see that? Cool. So what I'm actually going to do is in here, I'm going to say to it, look, I want these ferns to be on a grid size. Actually, I'll do it before the sample. Classic. There we go. I want these to be on a grid size of 3200. Quick heads up, if you ever want to profile your performance, you can go window profiling, and when you've got the thing selected, it'll tell you how long it takes. It is a little bit more fiddly when you do it with hierarchical instancing turned on, because it had to refresh there. But now if I go window profiling, it'll show you how long that particular component took to generate things. And these ferns take 98 milliseconds by default. But if I get this and I turn off collision on small meshes like ferns, it's like 10% of the time. It's really quite quick. So turning off overlap events and collision on things that don't need it is really important. The reason I've done that is I'm really quickly going to duplicate what we've already got, and I'm going to make a smaller grid that represents grass. We have some like dry plants. Yeah, you're good. And I'm just going to throw 2 in there. Cool. So I've got a couple of dry plants in there, and I do actually want this grass to be just really, really quite dense. Cool. And if I did that right, so we've got these meshes here. I could even go, dare I say, denser. All right, cool. So we have a lot of grass that's kind of spawning in right there, right? But the thing is, if I zoom in, notice there's no grass over there. It's only as I approach it that it's generating that grass for the first time. And obviously I'd need to figure out the right distances for these things. But the cool thing is, if I click on the grass, you can actually see that that's the size of the grid cell. And there's a number that stores the distance ratio for each grid region and what its fade out distance is or generation distance is. But like, if I split them up, I can now get away with using PCG as a really, 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 really good, landscape grass. Imagine landscape grass could query the world and find out all sorts of information instead of just, am I on grass or am I on the dirt layer, So I can use this for some pretty cool stuff, but I'm going to do one last little bit with my last 5 minutes, which is this. Right now, that grass is not spawning on top of meshes or anything like that. But a really cool thing that you can do, I used the project node before. Project gets one data set and throws it onto another data set. Engineer may not describe it that way, but it's definitely what it does. If you get these points and you're kind of, I'll do it here. That's just getting rotated, so I can do it here and it's fine. If I get these points, what I can actually do, there's 2 steps to this, actually. Step 1 is I need to project. Every time they applaud, it seems to time up with me adding a node. Like, thank you, projection, here all week. And I'm going to project against what's called a world ray hit query, which is basically like it does a bunch of traces down into the world and figures stuff out. And I can grab this and I'm going to turn off ignore self hits. That way I can trace against my own rocks. You get me? It's set to world static collision right now, which will be a problem because by default, these trees and stuff that we spawned, their collision, I'm just going to hit block all so that they block all. Great. If I come back here. Now, this didn't work. And a big part of this not working is a lot of this stuff happens simultaneously. If there's no reason for a dependency, it's like, I'll just generate my grass and my rocks at the same time. But we want to trace against those rocks. So we want to make sure those rocks exist before we've gone ahead and done that, right? So what I'm going to do is inside of this section, just before we do the projection, I'm going to be like, hey, I only want you. You'll be fine. Yeah, good. I only want you to have a dependency on these meshes. That should be a named reroute node, but we're tight for time. So what that means is this will only run when that runs. Okay. And I'm also going to go into projection. And I'll do a complex trace. Okay, good. And you can now see that that's putting the grass on top of everything, right? So we're actually tracing into the world. And I'm weirdly enough kind of covering all my rocks there. But a cool thing is like if you set up a collision channel that was specific to, there is a problem actually that I haven't shown you yet. You can see it up there. That's fine. What I would suggest doing is a few ways to dance around this. But if I disconnect my trees and instead of my trees being block all at the end. If I had like a landscape collidable collision channel or something like that, or I could tag them and do traces only against tag data that says, yes, I'm allowed to have grass on top of me, that would work too. Quickest, dirtiest way for me to resolve that though is honestly, if I just set you back to block all dynamic, I'm reasonably sure that'll clean it up. Yeah, so now grass is only projecting against the stuff that wasn't keep vertical. But we end up with kind of a cool result, right? And this is like, I've been explaining everything as I've been going, but when you really do know what you're doing, the capacity to do this is pretty wild. Like you can generate a lot of content really quick once you start getting used to it. And to that end, I really just want to highlight one last thing with my last minute and a half of this soapbox, which is I've gone ahead and I've demonstrated this using a forest. And everyone on YouTube, not everyone, but like 90% of PCG tutorials that you see are demonstrating forests as well. Because it's like, hey, we want to scatter some stuff. Oh man, we can get trees. This is cool. But I genuinely think PCG is going to work its way into like every project in the next couple of years. Because it's just it adds really small microdata, like just microscattering in whatever ways that you need it to. And this could be run at game time, like in gameplay, or it could be run statically, But it means that we can start doing things like when I put down a road, randomly place little tufts of grass just from the gutters in any area that I think, I've flagged as maybe it needed slightly more maintenance in that area. Or my kitchen areas can look for tables, and just automatically, whenever I add a kitchen or a home area, it's like, hey, I might scatter some mugs and some decals of just tiny little stains. Maybe I'm putting it in my world so that anywhere cars could potentially be parked, we're randomly dropping a couple of oil stains onto the world, and in doing it that way, I don't have to have a ridiculously complex material that accounts for what if this pixel is or is not oil stained. You know what I mean? Like, we can use a separate set of logic to push all of that off. And that means that there's performance gains, but also there's just artistic gains. And most importantly, they're artistic gains that are driven in a very similar way to when everyone learned the material editor. You know, as you started to get better and better at that, the control you had of your scene skyrocketed. And I genuinely think PCG is the same. So even though it's in its early state, and obviously some of the stuff I did there was a teeny bit clunkier than I'd like, I'm really, really excited about the future of it. I hope you check out the other PCG sessions that are coming up. Aaron Langmead has one that's right up next. But in the meantime, I hope this has been useful. I'm happy to chat PCG if you see me floating around at the Dev Hub. But thank you very much for your time. I hope you've been enjoying Fest.